If f of x equal to f, then limit extending to 0, 1 minus cos ax by f of bx equal to 0. For example, limit extending to 0, 1 minus cos 4x by 6x equal to 0. Limit extending to 0, 1 minus cos 2x by x equal to 0. Limit extending to 0, 1 minus cos 3x by sin 4x equal to 0. If f1 of x, f2 of x belongs to f, then limit extending to 0, 1 minus cos ax by f1 of cx into f2 of dx equal to a square by 2cd. For example, 1 minus cos 4x by x square is equal to limit extending to 0, 1 minus cos 4x by x into x. That is equal to 4 square by 2 into 1 into 1. Answer is 8. Limit extending to 0, 1 minus cos 5x by x into sin 3x is equal to 5 square by 2 into 1 into 3. The answer is 25 by 6. Limit extending to 0, 1 minus cos 2x by x into tan inverse of x equal to 2 square divided by 2 into 1 into 1. Answer will be 2. Next, if f1 of x, f2 of x belongs to f, then limit extending to 0, 1 minus cos to the power n of ax divided by f1 of cx into f2 of dx equal to n a square by 2cd. For example, limit extending to 0, 1 minus cos square of 3x divided by sin 2x into sin tan 3x equal to 2 into 3 square divided by 2 into 2 into 3. Answer will be 3 by 2. Limit extending to 0 of 1 minus cos cube of 2x divided by sin inverse of 2x into 3x. That is equal to 3 into 2 square divided by 2 into 2 into 3. The answer will be 1. If f1 of x, f2 of x belongs to f, then limit extending to 0, cos ax minus cos bx divided by f of cx into f2 of dx. Answer will be b square minus a square divided by 2cd. For example, limit extending to 0, cos 5x minus cos 7x divided by 2x into tan 3x. That is equal to 49 minus 25 divided by 2 into 2 into 3. The answer will be 24 by 4 into 3. Answer is 2. Limit extending to 0 of cos 4x minus cos 5x divided by x square. The answer is 25 minus 16 divided by 2 into 1 into 1. Answer is 9 by 2. Next H. If f1 of x, f2 of x belongs to f, then limit extending to 0 of cos raised to n of ax minus cos raised to n of bx divided by f1 of cx into f2 of dx is equal to n into b square minus a square divided by 2cd. For example, limit extending to 0, cos cube of 3x minus cos cube of 4x divided by 3x into sin 2x. The answer will be 3 times of 16 minus 9 divided by 2 into 3 into 2. The answer is 7 by 4. Limit extending to 0, cos square of 2x minus cos square of 5x divided by x square. The answer will be twice of 25 minus 4 divided by 2 into 1 into 1. The answer is 21. If f of x equal to f, then limit extending to 0, tan raised to n of ax minus sin raised to n of ax divided by f of x to the power n plus 2 is equal to n times of a to the power n plus 2 divided by 2. For example, limit extending to 0, tan square of 2x minus sin square of 2x by x raised to 4 is equal to 2 times of 2 to the power 2 plus 2 divided by 2. The answer is 16. Limit extending to 0, tan cube of 2x minus sin cube of 2x divided by sin raised to 5 of x is equal to 3 into 2 to the power 5 divided by 2. The answer will be 48. Limit extending to 0. 1 minus cos nx by 1 minus cos mx equal to n square by m square. For example, limit extending to 0. 1 minus cos 5x divided by 1 minus cos 4x is equal to 25 by 60. Limit theta tending to 0. Sin a theta minus sin b theta divided by m theta is equal to a minus b by m. For example, limit theta tending to 0. Sin 4 theta minus sin 6 theta divided by 5 theta is equal to 4 minus 6 divided by 5. The answer will be minus 2 by 5. Let f of x and g of x be the polynomials in x. Then limit extending to infinity, f of x by g of x is equal to ratio of the coefficients of highest power of x if degree of f of x equal to degree of g of x. The answer is 0 if the degree of f of x is less than degree of g of x. Infinity if degree of f of x is greater than degree of g of x. For example, limit extending to infinity 3x square minus 4x plus 7 divided by 7x square minus 1 is equal to 3 by 7. Because degree of f of x and g of x both are equal. And limit extending to infinity 4x minus 7 divided by 2x square plus 5, that is the second case, answer is 0. Limit extending to infinity 4x square minus 3x plus 1 divided by x minus 2 is equal to infinity, that is degree of f of x is greater than degree of g of x. That's why the answer will be infinity. Next, 12th formula, in that the first one. Limit extending to a, f of x to the power g of x is equal to e to the power, limit extending to a of g of x into f of x minus 1, provided limit extending to a, f of x equal to 1 and limit extending to a, g of x is infinity. Second one, limit extending to a, 1 plus f of x to the power g of x is equal to e to the power, limit extending to a of f of x by g of x. For example, limit extending to pi by 2, 1 plus cos x to the power tan x. Limit e to the power, limit extending to pi by 2, tan x into cos x, that is equal to e to the power, limit extending to pi by 2 of sin x, sin by cos get cancelled. And when you are applying that the sign of pi by 2, you are getting 1. Answer will be E. If f of x plus y equal to f of x into f of y for all x comma y, and f of k equal to L, and f dash of 0 is m, and f dash of k equal to Ln. For example, if f of x plus y equal to f of x into f of y for all x comma y, and f dash of 0 equal to 4 and f of 5 equal to 3, then f dash of 5 equal to 12. And next 14th formula. If f of x plus y divided by 2 equal to f of x plus f of y divided by 2 and f of 0 is 1, then f dash of a equal to f dash of 0. If f of x plus y equal to f of x into f of y, then f dash of a is into f dash of 0. If f of x plus y equal to twice of f of x into f of y, then f dash of a equal to twice of f of a into f dash of 0. Continuity and differentiability of a function. Definition. A function f of x is said to be continuous at x equal to a of its domain if number 1, f of x is defined at x equal to a. Limit extending to a of f of x equal to f of a. Or f of x is continuous at x equal to a if f of x is defined at x equal to a and left hand side of the derivative equal to right hand side of the derivative equal to the defined at the function at x equal to a. This is the one type. Second type, if a function f of x is not continuous, is nothing but discontinuous at x equal to a. The discontinuity of a function f of x at x equal to a may arise due to any one of the following cases. F of x is not defined at x equal to a. Second case, limit extending to a, f of x does not exist. Left hand limit, right hand limit exist if they are not equal. Limit extending to a, f of x exists but not equal to f of a. Suppose limit extending to a, f of x exists. Left hand limit and right hand limit exist and are equal, but it is not equal to f of a. Then by redefining the f of x can be made continuous at x equal to a. A function f of x is said to be differentiable at x equal to a of its domain if limit extending to a, f of x minus f of a divided by x minus a exists and is finite. This is denoted by f dash of a and is called derivative of the function x equal to a. Therefore, the function f of x is said to be differentiable at x equal to a if limit extending to a negative f of x minus f of a divided by x minus a. That is equal to limit extending to a positive f of x minus f of a divided by x minus a is equal to f dash of a. These are respectively called left-hand derivative and right-hand derivative of f of x at x equal to a and are denoted by L f dash of a and R f dash of a. Time savings results. Every polynomial function is continuous at every point on the real line. Second one, every rational function is continuous at every point wherever it is defined. Logarithmic function, exponential function, trigonometric function, inverse trigonometric function, and absolute value function are continuous in their domain. Every polynomial function, exponential function, and constant function is differentiable at each point of the real line. Logarithmic function, trigonometric function, inverse trigonometric functions are differentiable in their domain. If f of x is differentiable at x equal to a, then it is continuous at x equal to a. But the converse is not true. The absolute value function f of x is equal to mod x is continuous at x equal to 0, but not differentiable at x equal to 0. Thank you. This completes the limits and derivative.